My name is Matt with the National Weather Service Chicago office located in Romeoville. This is a look back at a heavy snow event that occurred on Tuesday, February 26th. This rounded out what actually was a pretty snowy month across northern Illinois into southern Wisconsin. And February put the end on generally what was not a snowy meteorological winter, at least across much of northern Illinois. Here's a look at the snowfall totals from this event, and this was a multi-day event developing in the southern Rockies into the southern plains, lifting northeast into the Great Lakes, and then even organizing further eastward into the eastern lakes in northeast U.S. You'll notice very heavy snowfall amounts with this. In the southern plains, this was complemented with extremely strong winds. This also produced a second snowstorm in just a week's time near Kansas City. And then also very heavy snowfall amounts occurred on the western fringes of Lake Michigan, including Lake and McHenry counties, which we will talk about. Here's a zoomed-in map to our local area here. You'll notice generally 3 to 6 inches fell north and west of Interstate 55. Amounts became quite a bit less as you drop south and east from there. You'll notice also that maximum we talked about near the Wisconsin state line. When meteorologists look for heavy snow forecasting, they diagnose several elements, and there are many more than can be listed than just the few on here. This particular list is also elements that we look for towards heavy precipitation really any time of the year. These are deep replenishing moisture that's very anomalous for the time of the year and is very deep through the atmosphere. The atmosphere remains saturated to produce precipitation. A real key is very strong dynamics. That really means the atmosphere has a lot of lift in it. It's causing a lot of lift and ascent, leading to condensation and growing water droplets or snowflakes that fall down to earth. Instability. Instability is key in the thermodynamic world. That will lead to even more rapid ascent and potentially explosive rates of precipitation. A focus or a concentration, such as a front or a boundary. And then in the wintertime, we look for the ability to really increase snowfall rates by having just simply larger diameter snowflakes, or what meteorologists sometimes call dendrites. Here's a look at the GOES satellite water vapor loop from the afternoon of the 25th into the morning and afternoon of the 26th, which is the day we had the heavy snow. You'll notice a classic mid-latitude cyclone, as we call this, and it's an expansive one. This is really a massive system. It has deep moisture coming northward from the Gulf, dry air wrapping around from the southwest U.S. As it takes this path northeast, this is generally a favorable track for the area to receive snow in the winter or early spring, but also to potentially receive heavy snow. Here's a look at weather maps at about 5,000 feet up during the morning of February 26th. At this time, heavy precipitation was spreading northward. You'll notice in the red shaded area in the leftmost map, the warm air advection highlighted, strong warm air advection. Generally, warm air advection is associated with ascent, as meteorologists call it isentropic ascent. This ascent can be very gradual or it can be very strong. In this particular graphic, it looks like it's pretty strong, and indeed it was this morning on the 26th. On the rightmost image is moisture return at that 5,000 feet. Very strong moisture coming back from the Gulf of Mexico, wrapping up into the Ohio River Valley, and then turning quickly to the west into our area. This is generally a good large-scale signature for the area to have more efficient precipitation rates due to just simply more moisture in this warm air advection scheme. Here's a look at that radar during this time, during the morning hours. This is generally from 7 to 10:30 a.m. or so. You'll notice the very high DBZ coming north with the radar here. DBZ of 40 plus is uncommon in the wintertime. Some of this is bright banding on the radar, or the radar energy is basically striking water-coated ice and leading to a very high power return. Some of this, though, is legitimately heavy precipitation, whether it be sleet or rain, or in a few cases here already heavy snow that the radar is seeing. Here's a look at the morning weather balloon launch at the National Weather Service office in Lincoln. A couple things to note here. A good portion of this sounding, the atmosphere diagnosed in this sounding, is above 4 grams per kilogram of mixing ratio, and that's what's highlighted here. Generally 10,000 feet and below is above that. To meteorologists, that signifies a lot of moisture, especially in a potential snow event. And some of the mixing ratios were analyzed to be even over 6 grams per kilogram in part of our area. Very high moisture, very efficient potential precipitation rates. Another thing to note are these lapse rates. In general, in the cool season, this is a pretty deep layer and unstable layer just by eyeballing it from the sounding. And this is within and above the moist layer, also a good placement. Again, that can help for heavier precipitation rates, just more ascent. And this was all upstream of the area, so this was being pushed in or advected into our area. Here's another look at a sounding. This one's from Midway Airport and actually comes from an aircraft that was ascending from there near 9:30 a.m. I'm going to highlight the 0-degree isotherm, the freezing line basically in the atmosphere. Notice part of the sounding above that, and at first glance it may look like this will produce a few different types of precipitation. And indeed the precipitation did start as a sleet, rain, and snow mix. But there is quite a bit of dry air, allowing for evaporational cooling, and with the strong dynamics moving northward with the system, together this looks like this would cool to produce snow, and indeed that would be the case fairly quickly. One thing to note, though, is that the near surface temperature is above freezing, the boundary layer temperature, and that is a concern with meteorologists during these late winter, early spring systems here. That warm air near the ground, and potentially even warm ground itself, may lead to the snow melting right away, especially if rain's fallen beforehand and the ground is wet too. The precipitation rates may need to be pretty heavy to get accumulation. So that was one concern going into this event. Here's just a freeze frame of that radar we looked at earlier. The dashed lines indicate strong convergence, one of the things meteorologists look for to indicate a focus, something we talked about earlier. Here's a highlight of that strong focus. Here's a couple hours later showing the focus moving in towards the south side of the city. A very tight reflectivity gradient and a strong convergence of deep moisture here. Just a really good focus. And this would continue to move northward and even intensify as it reached the northern part of the Chicago metro area. Snowfall rates in that area would be explosive, very high. Rates over 1.5 inches per hour, in cases over 2 inches per hour, were reported to us from our great networks, our spotter network, our co-op and CoCoRaHS networks, as well as public reports through our social media platforms. On the right-hand side, you'll notice visibility at Waukegan Airport being 1/4 mile or less for several hours in heavy snow. Generally, that equates to 1.5 inches of snow per hour or greater, and especially in those cases when there are larger diameter snowflakes, those dendrites we talked about, and several reports from public and spotters indicated that we did have larger diameter flakes falling in the heart of this, leading to very rapid accumulations. Here's a look at the radar during this time into Lake and McHenry County, showing very high DBZ, 35 plus DBZ, and some of those darker green shadings across northern Lake County that lasted for 1.5 hours and even longer. That's impressive duration there of high reflectivity, indicating very heavy snow in this case. This is a look at a radar later in the afternoon between 5 and 6 p.m. A couple features to note here, kind of a swath of heavier precipitation coming in off of the lake. This was seen a few times during this event. While it's not likely true lake effect snow, it may be some lake enhancement due to just higher moisture or potentially just some convergence there caused by air moving over the lake and the orientation of the shoreline. That was even more so potentially seen in this north to south axis here, where in a radar loop it could be seen that there was clearly high reflectivity there that would be very pronounced over that area, and that may be enhanced convergence from the frictionless lake to the friction over the land that potentially caused that. Again, the wind was very strong from the east-southeast, likely grabbing a lot more moisture from the lake and potentially causing some localized or mesoscale factors that led to very high snowfall amounts. They already would have been high, but this may have even made things a little more efficient. So again, a late winter, early spring classic low pressure system has many challenges to meteorologists. The number one being that the temperature profile may allow for rain or all snow, and it's a very fine line, and all snow obviously can have significant impacts. Anything in between, of course, freezing rain and sleet can as well. This was an efficient snowfall maker due to very high anomalous Moisture values, whether it be mixing ratios, precipitable waters, very high. Local, small-scale factors can lead to rapid differences in weather. Obviously, a lake breeze is just one instance of that. But also, things such as snowfall rates can vary significantly, potentially due to local factors. You can find out more about this event by visiting our webpage at weather.gov/Chicago. Thank you.